All right, so I want to revisit the example from the previous video where we set a glass of water out on the counter, and then eventually we said over time, all of those water molecules are going to get a sufficient amount of energy to vaporize. But what happens if we put that same water, that same cup, and we put it in a sealed container? What's going on with this process? Is there still vaporization? And the answer is yes, that there is still this phenomenon of some of the water molecules vaporizing into a gas. But at the same time, those gas molecules are condensing back into liquid. And so if we set that cup out, that sealed container, for the same amount of time as we did the other example, what we would see is that there would be no change in volume. And this looks like nothing is happening. But something is happening. The water, liquid water, some of it is vaporizing into a gas, and some of those gas molecules are condensing back to a liquid. And we call this a dynamic equilibrium. And you'll see, I've drawn this like a chemical equation, and I'm using this weird looking kind of two-sided arrow or half arrows. And you're gonna see this a whole lot in the next semester. But that is the arrow that we use to demonstrate what is known as equilibrium, which basically for this particular instance, the rate of vaporization is equal to the rate of condensation. So as water is evaporating, water vapor is condensing. And this is the state of balance between continuing processes. So even though it looks like nothing is happening, there is still a lot happening. The liquid water is vaporizing, but that is occurring at the same rate that the water vapor is condensing. So while the net result to our eyes looks like there's been no change, that's because the rates of the two things happening, the rates of the two things happening are equal to each other. So at the end result, there has been no change in the level of the water. Now, that water vapor above the water, so this water vapor exerts a pressure on the liquid water. And that is something that is known as vapor pressure. Vapor pressure is the pressure exerted by a vapor above a liquid. Much like atmospheric pressure would press down on the liquid, in this case, in a sealed container, it's the water vapor that is pressing down on that water. And the key thing to note is that the weaker the intermolecular forces, do you think if a liquid has weaker intermolecular forces, it's going to produce more or less vapor? It'll produce more vapor. And if it's in a sealed container, that means it will exert more vapor pressure on the liquid in the container. Now, in the next video, we're going to look at this relationship between vapor pressure and a physical property that we know as boiling point. And we're going to look at a new type of definition for what boiling point is.